Hi guys, I just want to start off by saying that I miss you and I can't wait to come back and see you guys. I want to give you a couple of little reminders. If you watched Mr. Wickland's video at the beginning, he talked about that you can leave a message in the question section to ask us questions. If you want to email us, or if you're not on Google Classroom, if somebody just sent you this video, then you can email me at amontgum, it's just like Montgomery, at tps.org, all right? Or if your parent is one of the parents that I'm texting, have them reach out to me that way. However you need to get a hold of me if you have any questions that I don't cover. I'm going to go through this a little bit quickly. Your guys' packet I don't think is too difficult for you guys. I just think that we didn't talk about the number chips model, or the chip model, very much. So I'm going to go through that kind of quickly with you. We did our integers using a number line, because remember that's what our standard said. It said we need to know how to use the number line. And I told you guys, I showed you the chip model because I told you that's how my brain works. The chip model works better for me. Everybody likes something different. We also made our foldables with our rules, so you guys should have those at home to help you. But if you don't worry, you can either find them online, or I'm going to show you how to do the chip model here. Your packet talks a lot about using the chip model, so I want to make sure you know how. So just a reminder, when they say chip model, they're just talking little like discs. We talked about how there's like a lot of times they use red and black to be positive and negative, or red and yellow. We're just going to use positive, negative. That's all. Okay, positive and negative. So first let's talk about what happens when you have one positive and one negative. Right here, just like this. They equal 0, right? If I have 1 minus 1, they balance out to 0, just like if I'm here. The middle of those is 0. So we call this a 0 pair. Sometimes we show it like that to show that it cancels each other out. Okay, so I'm going to leave that up there because we're going to use that a couple times. So just some quick little problems here. We're going to do 4 plus negative 3. Sorry, my board's really wiggly. So this means I have 4 positive chips. 1, 2, 3, 4, and I'm adding to it 3 negative chips. Okay, then from there I just go through and I find my 0 pairs. Here's 1 0 pair, 1 0 pair, and 1 0 pair. What am I left with? I'm left with positive 1. So let's double check that. We use the number line method a lot. Let's double check it up there. So we're starting at 4. We're moving backwards 1, 2, 3 because we added a negative, and we landed right at 1. Okay, so it gets you the same thing. It does the same thing. When you're doing it on your own, it doesn't matter if you use this method, or the rules that we put in our foldable. The rules are the easiest way. They don't require you to draw out a number line or draw out chips. So it's probably the best way to really learn how to do them. But this packet specifically asks you to draw a chip model for a lot of your problems. Okay, so let's do another one. Let's do negative 4 plus 3. This means I have 4 negatives, and I'm adding to it 3 positives. So when I have my 0 pairs, what am I left with? Now I'm left with negative 1. Okay, we can see that that one's different because it started at negative 4, and it added 3, so it went forward 1, 2, 3. And it landed at negative 1. So that's how that one's different. And we can see that with our chip model. We can see it with our number line model. Okay. Now if we have negative 4 plus negative 3, this means I have 4 negatives. And I'm adding to it 3 negatives. What do I have? 7 negatives. That's it. Okay, so what happens if you have to do a subtraction problem? Well, if we have negative 4 minus negative 3, 4 negatives, take away 3 negatives. What do I have left? Negative 1. Okay, so really simple when you're taking away, cross them out. The only thing that gets tricky when you're doing a subtraction problem is if you have, let's do positive 2 minus negative 3. Well, if I have 2 positives, how do I take away 3 negatives? The only way to get 3 negatives on my board without changing the amount I have is to add a 0 pair, because now this is 2 plus 0, still 2, right? Let's add another 0 and another 0. And I could add as many zeros as I want, but I need 3 because I need to take away 3 negatives. So now I can take these 3 negatives away, and what do I have left? 1, 2, 3, 4, 5. Positive 5, okay? That's the only one that's maybe a little bit trickier, just because you have to think about how to add something before you can take it away. But remember, we talked about when you take away a negative, these two, those double negatives, they cancel each other out. So we move forward or to the right on our number line. That's why our number got bigger, even though it was a subtraction problem, okay? Multiplication works the same way. 2 times -3 means I have 2 groups with 3 negatives in each. 1, 2, 3, 4, 5, 6. So I have 6 negatives. Well, 2 times 3 is 6. A positive times a negative is a negative. Okay? I don't think it asks you about division, so if you get to that point and it does, remind me and I'll help you. The last thing I want to talk to you guys about is just division with repeating decimals, because that was something we worked on in class, but it's also something that they give you in this packet. So if I have 3/9, this, we read this, 3 divided by 9, okay? 3 divided by 9. If I put that 9 on the inside, this says 9 divided by 3. And 3 goes into 9 3 times. My answer should not be 3 wholes. When I have a fraction like this where the top number is smaller than the bottom, my answer should be a decimal, right? So we want to put 3 on the inside. Your top number, your numerator, always goes on the inside. 3 divided by 9. So can 9 go into 3? Nope. Goes in there 0 times. So here's where we add our decimal and our 0. Because remember, 3.0 is the same thing as 3. I can add as many zeros out here as I want, right? Okay, I'm just going to add 1 for now. 9 does go into 30. I'm going to treat this just like a 30 and ignore that. 9 goes into 30 3 times, and 3 times 9 is 27. 30 minus 27, 30 minus 27 gives me 3. And I can already see what's happening. I have a repeat. Anytime I start to see something happening over and over again, I know that my answers are repeating decimal. But if I don't see it yet, I can add another 0. Bring it down. How many times is 9 going to 30? And now I might start seeing my pattern. Goes in there 3 times, gives me 27. I'm going to keep doing this over and over if I keep going, right? So I'm going to stop right here. My answer is 0.3 repeating. Okay? So let's do one more. So I'm going to do 4/11. 4 divided by 11. That means 4 is on the inside, 11's on the outside. Can 11 go into 4? Nope. So it's a 0. We're going to add all our decimals and our zeros. We're going to treat this like 40, even though it's actually 4.0. And 11 does go into 40, not evenly, but it goes in there 3 times. 3 times 11 is 33. 40 minus 33 is 7. Now I didn't get a repeat, so I have to keep going. I'm going to add another 0, bring it down. 11 goes into 70 6 times. 6 times 11 is 66. And 70 minus 66 is 4. Now I think that this means I've got my repeating pattern. Now if I can't remember and I want to double check, add a 0, bring it down. 11 goes into 43 times. 11 times 3, or 3 times 11 is 33. 40 minus 33 is 7. I can see what's happening here, so I know my next number is going to be a 6. So my answer looks like this. Don't forget that that repeating sign goes over both the 3 and the 6, okay? There is a difference between this and this. This means 0.363636 0.36 forever. This one means 0.36666 forever. Just the 6 is repeating. So make sure if you have both numbers repeating that the repeating line goes over both numbers. All right. If you guys have any more questions for me, go up to that top of that Google form and fill out the question. Or like I said, if you got this video from somebody else, because it will be a YouTube link, email me, email your teacher, whatever you need to do to get a hold of me. I'll be happy to help you. All right. I hope to see you guys in May. Stay safe, stay healthy, and stay home. Bye-bye.